Hello and welcome to today's video. On the workbench today we have the newly rebuilt half bridge for the AMC325 motor controller. This is the one that everything blew up on. Well, not everything, all the MOSFETs blew up. I replaced all the MOSFETs. You can see my soldering is not as good as theirs. I used Big Bertha there to connect all the pins together, but went ahead and rebuilt it. Replaced all 16 8 on this side and 8 on this side power MOSFETs, and on the high side, which this is the high side here, all of the gate drive resistors have also been replaced because a lot of them exploded when it shorted to ground. So 150-ish, 157 volts passed through all those gate resistors when they died, so replaced all them. This is the all the parts that got swapped out, so you can see lots of lots of MOSFETs that are exposed that really shouldn't be exposed like that. Like, you shouldn't be able to see the die. Those ones are all blown open because the pins, or not the pins, but the bond wires are physically gone. They've vaporized. But the majority of them were blown open. The ones that are where the tops are just missing, they blew open. The remaining ones were either shorted, or there were a few that were still good, but I replaced all of them. We're not going to have any kind of a mix or anything. We want them all coming from the same batch so they share current very evenly, and don't trust them because they were exposed to pretty high current. So we want to make sure that they're good. So they're all brand new, and yeah, should be pretty good here. I've got the meters, so we can go ahead and show you that if I touch like that, so we're measuring the 0.415 volts. This is the internal diode, body diode of the MOSFET for this side, and then if we go over here, this is the actual diode on the inside ones. So you can see that reads 0.315. The actual diodes are better than the body diode in the MOSFET. And if we flip this the other way, we can measure the diode on this side, on the inside. So when I say inside, the 8 on this row here are the diodes that we're measuring now. You can see that that's 0.319 volts. And then if we measure over here, you can see we get 0.415 volts, and that's the body diode on the outside ones MOSFETs. The internal diodes are only used for regen and for inductive clamping, and then the outside MOSFETs obviously are the ones that conduct to transfer energy to the motor, generate the rotating stator field. And just to show that it is repaired just like the other one, so we can go ahead and move him out of the way here, and I'll just go off of this one. So do the exact same thing and show you that the results are the same. So there's your 0.317 volts for the inside diodes for that, and then we'll go over here, 0.416 volts. That's the body diode of the MOSFETs on the other side. Flip the probes around again and do the same thing. So this is 0.417 volts, which is the body diode of these MOSFETs, and they're all in parallel. And then if I can get over here, 0.317 volts, which is the diodes on the inside, this inside thing. So yeah, I could do the last one too, but they're identical. So this has been completely repaired. Before it was all shorted and it was just dead. So that's been fixed, so that's ready to go. Ready to put the power stage back together. You can see all the we had one other casualty here I should probably mention. This is the capacitors from the middle phase. They plug in the top here, right, like that. And it had you can see how it looks a little silvery, this capacitor. That's because it's all metallized. We had a little bit of an arc through here at this point, and it blew up the contact for the capacitor. It also permanently welded the other screw, the other bolt, into the capacitor, so when I try to unbolt it, I broke the head off. It is one with the metal now. It arced pretty good. I don't know how many joules of energy these guys store, but it's a 1500 microfarad capacitor. It would have been charged at about probably 160 volts or so, depending on what the state of charge of the battery pack was. But when it let go, it welded that. So we're going to replace this capacitor anyway. It's a little bloated because a lot of energy was dissipated in it. And if I had the screw in there, it actually looks like it's splaying out. So this guy's bad. Go ahead and replace that one. The other one looks okay. And all the other caps look fine. So we'll just go ahead and replace that one. And other than that, so we'll rebuild the power stage to the bus bars and everything. You can see those are all the screws and everything. We'll replace the fuse because that died as well. And yeah, many screws hold this thing together. There's a lot of labor involved, including all these nuts and bolts that had to go in there to take all those guys out and unsolder all of them. If you watch some of if you look at the pictures, if you don't know where to find pictures, they're actually always, if you go to the playlist for this battery charger repair, and it has a link to the actual pictures. But you'll see I actually, when I take all these out, I actually leave 2 in to support the copper bar. Or, well, I leave all of these pins intact. I replace the outer 2 ones first to support the copper bus bar and make sure I soldered those back in. And then I go replace all the other ones and pull those out. That's just to maintain this height. We want that to stay exactly the same height. We don't want to accidentally move that because then things won't line up when we go to put it back together. So that works out pretty well to do it that way. The only difference is you can kind of see like where I heated it up to solder each pin. I don't ever want to flow the entire copper bar. If I do that, it'll fall off and then we'll lose that height. So there's a reason. If you look at the pictures, you'll see what I'm talking about. After that, all we got to do is middle gate driver is bad, so we're gonna have to troubleshoot that and repair it. What I usually do is I'll rebuild the entire controller and put the gate drivers back in, or not in, but leave them out, and then just hook up the scope, and then hook it up to the motor to where it's not spinning, or bypass it so it's doing a slow sine wave. Essentially, it's in volts hertz mode, and I can see the PWM attempts, and I can trace that back through the gate driver to find what's all failed in it. And if people are interested, I can do that on the scope, and we can just essentially backtrack through, because they're all identical, so you can actually compare signals between 2 different phases, and use that to backtrack, figure out how bad it is, how much damage it propagated through. I know for sure that a couple of the, well, on the middle one, the 2 output stages are definitely dead because they're shorted. So I'll just unsolder those first, and then hopefully it's just that, and I think I have some replacements for those, and we should be able to get back up and running, and then we'll have the motor controller all back together, and hopefully it works. So anyways, this is a much longer video than anticipated, but thanks for watching. Bye.